Hello students, welcome to CREATA classes. I am Gurmeet Singh and also welcome to the lecture number 7 of probability series. In this lecture, we will take down question number 11 to question number 20 of exercise 15.1 for 10th math student. The link to the other videos of the probability series is given in the description. Check it out. So without taking any further time, let's start with our next question, that is question number 11. Here it is. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish? We will go step by step. Our first step is to observe the question and visualize the question. Only after that we will follow the second rule, that is using the formula. So let's observe the question. In this question, Gopi goes to the market to buy the fish for his aquarium at the home, and the shopkeeper is having the fish tank which is having some fish. In the question it is given that the fish tank is having total 5 male fish and 8 female fish. The shopkeeper takes one fish at random from that fish tank and gives to Gopi. So the question is, what is the probability that the taken out fish is a male fish? So this is what is given in the question. Let's take down the formula of the probability, and as usual we will start from the denominator. In the denominator, what are the total possible outcome will be there? We are having total 5 male fish and 8 female fish. So the total outcome will be 5 male and 8 female fish. That will be equal to total 13 fish in the denominator. So we got the total outcome as 13 in the denominator. Let's check out what the numerator is holding for us. Numerator is the favorable cases. Our favorable case is getting the male fish. The fish tank contains 5 male fish, that is our favorable condition. So all these 5 male fish will come in the numerator. So we got 5 male fish in the numerator and total 13 fish in the denominator. So we got our answer as 5 by 13. So we have done the question number 1. Let's move to question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8, and these are equally likely outcomes. What is the probability that it will points at? The 4 subparts are given. First 8, second an odd number, third a number greater than 2, fourth a number less than 9. So this question is having 4 parts. Let's take down this question. A game is given in which we have to spin an arrow. This is the game and this is the arrow. This circular game or this board is having total 8 segments, and we have to rotate this arrow, and the arrow will rest at any one of the 8 segments or the 8 parts. And we have to calculate the probability of resting this arrow in different 4 scenarios. Let's take the first scenario, 8. What is the probability that this arrow will rest at number 8? So let's take the formula of the probability. As usual, we will start from the denominator, that is total possible outcome. We are having total 8 segment, 8 number, so the total possible outcome will be 8. Let's move to numerator, the favorable outcome. The favorable outcome of getting 8 is the segment 8. So in the numerator only one segment will come, that is segment 8. So we got our answer as 1 by 8. 1 in the numerator because the number 8 segment is only 1, and total we are having 8 segments, so 8 in the denominator. Let's move to the second part, an odd number. What is the probability that the arrow will rest at any of the odd number? Let's try to identify the odd numbers. In this, the odd numbers are 1, 3, 5 and 7. We are having total 4 odd number segment. So in the numerator, the favorable condition are total 4, that is 4 odd number segment, which are 1, 3, 5 and 7. So in the numerator, the 4 will come, that is the 4 segment. And in the denominator, the total possible outcome, we are having 8 segments, so in the denominator 8 will come. We got 4 by 8 as the probability, which is 1 by 2. The third part, a number greater than 2. What is the probability that the arrow will rest at number greater than 2? So what are the number greater than 2? It includes number 3, 4, 5, 6, 7 and 8. So total 6 segments are greater than number 2. So in the numerator we got 6 and in the denominator we got total 8 segment. So we got our answer as 6 by 8. Are you understanding why we are using the 8 segment in the denominator? In all the cases, the total possible outcome will be 8, that is 8 segment. So we are taking 8 in the denominator. In the first case I have covered, so I am not repeating the denominator portion in the rest of the cases. Okay. The fourth part, a number less than 9. So what is the probability that the arrow will rest at any of the segment less than number 9? So let's identify what are the number less than 9. It includes all the number 1, 2, 3, 4, 5, 6, 7 and 8. So in the numerator all the 8 segments will come, and in the denominator again all the 8 segments will come. So we got our answer as 8 by 8, that is 1. 1 probability symbolizing 100% possibility. It means that the possibility of getting number less than 9 is 100%. If you observe, the arrow will rest at any of the number from 1 to 8. So the possibility of resting of this arrow on any of the number from 1 to 8 is 100%. That is sure event, 100% possibility. Just try to analyze what the answer is in terms of theory. We got the answer as 1, that is very nice. But what does this 1 symbolizing? 1 is symbolizing the sure event, that is 100% possibility of that event. So we have done the question number 12. Let's move to question number 13. A die is thrown once. Find the probability of getting first a prime number, second a number lying between 2 and 6, third an odd number. So this question is having 3 parts. Firstly, let's understand the question. A die is thrown once. So what are the possible outcomes that we can get by throwing the dice? We can get total 6 outcomes. That is number 1, number 2, 3, 4, 5 and 6. The question framer is asking to calculate the probability of 3 different scenarios. In the first scenario, the number outcome is a prime number. So let's take the first case, the prime number. So what are the prime numbers? The prime number from 1 to 6 include the number 2, number 3 and number 5. These 3 numbers are the prime number. So what is the possibility of getting the number 2, number 3 and number 5 when rolling the die? So we have simplified the question. Let's take the formula of the probability. We will start with the denominator, that is total possible outcome. When we roll the die, the total possible outcome are total 6 outcome, that is number 1, 2, 3, 4, 5 and 6. All these 6 numbers will come in the denominator. So we got 6 in the denominator. Let's check out what is in the numerator. In the numerator, we have to find the favorable outcomes. So the favorable outcome for the prime numbers are 2, 3 and 5. So these 3 numbers will come in the numerator because these are the prime number and our favorable outcome. So we got 3 in the numerator, 6 in the denominator. Our answer is 1 by 2. Got it? Here the trick is to identify what are the prime numbers. So you should know the other concept of the mathematics too. Okay? The second part is a number lying between 2 and 6. So we have to find the probability of rolling the die when we get the number between 2 and 6. So what are the number between 2 and 6? We got 3 numbers between 2 and 6, which are 3, 4 and 5. So what is the probability of getting the number 3, 4 and 5 when rolling the die? Let's take the formula of the probability. In the denominator, the total outcome is again 6, the number from 1 to 6. And in the numerator, the number between 2 and 6 will come, that is our favorable condition, which are 3, 4 and 5. So we got 3 in the numerator and 6 in the denominator, that is 1 by 2. Okay. Let's move to the part 3. An odd number. What is the probability of getting an odd number when we roll the die? So what are the cases of odd number in rolling the die? In rolling the die, that is from 1 to 6, the odd number are 1, 3 and 5. So we got 3 odd number that will come in the numerator. Number 1, number 3 and number 5, that are total 3 numbers. And again the 6 output in the denominator, that is 6 in the denominator. So we got our answer as 3 by 6, that is 1 by 2. Got it? We have used the concept of the number theory and also the concept of probability to solve this question. Mathematics is interesting when there is a combination of different concepts, like here the number system and the probability. So that's for this question. Let's move to next question. One card is drawn from a well shuffled deck of 52 cards. Find the probability of getting 6 parts are given: a king of red color, second a face card, third a red face card, fourth a jack of hearts, fifth a spade, sixth a queen of diamond. Let's observe the question. Check the link in the description. We have prepared a special lectures related to the cards. So if you want to understand the theory or the basic concept of the cards, everything about the card, go to the link in the description. So let's observe the question. In this question, we are having total 52 cards. So these are the total 52 cards. Some are face card, the number cards, the ace card. So different cards are there. So let's take down the formula of the probability. So this is the formula. We will start with the denominator, that is total possible outcome. So what will be the total possible outcome? We are having total 52 cards. So all these 52 cards will come in the denominator. So we got 52 in the denominator for all these 6 cases. So I will not repeat this concept. That is, in the denominator, the total possible outcome will come, that is 52. That is 52 cards. Okay. Let's take our first case, a king of red color. If you observe the 52 cards, how many cards include a king of red color? These 2 kings are of red color. So in the numerator, the favorable condition will be the 2 king of red colors. So these 2 cards will come in the numerator because these are the favorable condition. So we got our answer as 2 by 52, that is 1 by 26. Second, a face card. So what are the face cards? So out of these, each category is having 3 face cards. So we are having total 4 categories, that is 12 face cards will be there. So the favorable condition are 12 face card, so 12 will come in the numerator and 52 will come in the denominator. So we got our answer as 12 by 52, which is basically 3 by 13. Got it? Third, a red face card. We are having total 12 face card, out of which 6 are red and 6 are black. So in the favorable condition, that is in the numerator, the 6 red face card will come. So we got 6 in the numerator, 52 in the denominator. We got our answer as 6 by 52, that is 3 by 26. Fourth part, a jack of hearts. Out of this 52 card, the jack of heart is only 1. So in the numerator, the favorable condition is only 1, that is a jack of heart. So we got our answer as 1 by 52, 1 in the numerator and 52 in the denominator. Got it? I'm going slightly fast because we have already done all this concept. If you want to refresh or if you want to relearn, just go to the description and check out the link. This concept is very important and very tricky and very interesting too. You will have fun. So let's move to the fifth part, a spade. So if you check all the 52 card, what is the possibility or what is the favorable case of the spade cards? We are having total 13 spade card. So the favorable outcome are 13 spade card. So we got 13 in the numerator, 52 in the denominator. On solving, we got our answer as 1/4. Got it? 13 spade card in the numerator. Sixth, the queen of diamond. So out of this 52 card, we are having only one queen of diamond. So the favorable outcome in the numerator, that is queen of diamond, will be only 1. So 1 in the numerator, 52 in the denominator. Our answer is 1/52. Very interesting question. We have solved the question number 14. Let's move to question number 15. 5 cards, the 10, Jack, Queen, King and Ace of diamonds are well shuffled with their face downward. One card is then picked up at random. First part, what is the probability that the card is the queen? Second, if the queen is drawn and put aside, what is the probability that the second card picked up is A, the ace, B, the queen? So let's observe the question. This question is only talking about 5 cards. We are not having the full pack of 52 cards. We are only having 5 cards. So these are the 5 cards. We have to find the probability of different scenarios. We will take the first scenario, that is, what is the probability that the card is the queen? So let's take down this question. We will start with the denominator. So in the denominator, the total possible outcome will come. We are having total 5 cards. So in the denominator, all these 5 cards will come. So we got 5 in the denominator. And in the numerator, we have to find the probability that the card is the queen. So the favorable outcome of getting the queen out of this 5 card is only 1 queen. So 1 queen will come in the numerator. So we got our answer as 1/5. 1 in the numerator, only 1 queen is there, and we are having total 5 card, so 5 will come in the denominator. Second part of the question, if the queen is drawn and put aside, what is the probability that the second card picked up is first and ace? So in the second part, the queen is drawn and put aside. So the queen is taken and we have put it aside. So now we are having total 4 card. Queen is not the part of the pack. We are having only 4 card. And we have to find the probability of getting an ace. So let's take the formula of the probability. We will start with the denominator. What will be the total possible outcome? We are having 4 card, so 4 will come in the denominator. These 4 card will come in the denominator. Let's take down the numerator, the favorable cases. So the favorable cases of getting an ace is only 1. So only 1 ace card will come in the numerator. That is 1 in the numerator. So we got our answer as 1/4. So we got the part A of second part. Let's move to B, a queen. So what is the possibility or the probability of getting the queen out of this 4 card? This 4 card is not having any of the queen, so possibility of getting the queen is 0. That is impossible event. We can use the formula, that is in the denominator number 4 will come, that is 4 card, and in the numerator 0 will come because the favorable outcome is queen and we are not having any of the queen. So 0 will come in the numerator, that is answer is 0. That is impossible event. So we have done with this question. Let's move to next question. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at the pen and tell whether or not it is defective. One pen is taken out at random from the lot. Determine the probability that the pen taken out is a good one. Let's observe the question. In this question, we are having 132 good pens and the 12 defective pens are added accidentally. Now we are having a mix of 132 good pen and 12 defective pen. That is, we are having total 144 pen. One pen is taken out randomly from this total pack of 144 pen. We have to find the probability that the taken out pen is a good one. Very simple question. Let's take the formula of probability. We will start with the denominator, that is total possible outcome. The total possible outcome are total 144 pens. So 144 will come in the denominator. Let's look at the numerator, that is favorable cases. So the favorable cases of good pen are total 132 good pens. So 132 good pens will come in the numerator, that is favorable cases. So we got our answer as 132 upon 144. On solving, we got 11 by 12. Let's move to next question, question number 17. A lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that the bulb is defective? So let's solve the first case, then we will move to the second case. In the first case, a lot of 20 bulbs are given. We are having a lot and it includes 20 bulbs. It contains 4 defective bulbs. Okay, 20 bulbs and 4 are defective, means 16 are working good. One bulb is drawn at random and we have to find the probability that the bulb is defective. So let's use the formula of probability. In the denominator, the total possible outcome will come. We are having total 20 bulb in the lot. So 20 bulb will come in the denominator. And in the numerator, we are having 4 defective bulbs. So in the numerator, the favorable case, we are having 4 defective bulbs. So 4 will come in the numerator. So we got our answer as 4 by 20, that is 1 by 5. So we have got the probability of the defective bulb as 1 by 5. Let's take the second case. The second case is, suppose the bulb drawn in the one, that is case 1, is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that the bulb is not defective? So this second case is the continuation of the first case. In the first case, out of the 20 bulb, we have taken the one bulb, and the second case is saying that the bulb drawn in the first case is not defective. So we have taken the good bulb in the first case. So now we got total 19 bulb, 4 are defective and 15 are good one. Now again at random, one bulb is again taken out of this total 19 bulbs. And we have to find what is the probability that this bulb is not defective. So let's again use the formula of probability. In the denominator, total possible outcomes will come. That is total 19 bulbs. Note that now we are not having 20 bulbs, that is in the first case. In the second case, we have used only 19 bulb, as one bulb has already been taken out and used. So we are having now 19 bulb, so 19 will come in the denominator. And what will come in the numerator? Think. In the numerator, the favorable cases will come. And what are the favorable cases? We have to find the probability that the bulb is not defective. So the favorable cases of not defective bulb will come. Note that in the first case, we have calculated the probability of defective bulb. Now we are calculating the probability of not defective bulb. We are having total 15 not defective bulbs, that is total 15 good bulbs. So 15 good bulbs will come in the numerator. So we got our answer as 15 by 19. Just try to understand what the question framer is asking in the question. You have to focus on the wording of the question. Whether not is used, good bulb is used, defective bulb is used, one bulb is drawn or not. All these cases plays very important role in deciding the numbers in the formula. Okay, rain sound in the background. I am sorry for that. Rain is going on, so sorry for the rain sound. Let's move to the next question. Question number 18. A box contains 19 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears first a two-digit number, second a perfect square number, third a number divisible by 5. So let's observe the question. A box contains 90 discs and the discs are numbered from number 1 to 90. That is, number is written on all the 90 discs, and one disc is drawn at random from this box. So we have to find the probability that the taken out disc contains a two-digit number in the first case. So let's take the formula of probability. We will start with the denominator, that is total possible outcome. We are having 90 discs in the box, so the total possible outcome will be 90 discs, that is 90 in the denominator. In the numerator, what will be the total favorable cases? The favorable cases will be the disc having two-digit numbers. So we are having total 90 discs. In which disc the two-digit number will come? That will come from the disc numbering from number 10 up to number 90. The disc from number 1 to 9 will be having single digit number, and the disc from number 10 to number 90 will have two-digit number. So what will be the total disc? We can subtract the total 9 disc from the total 90 disc. We will get 90 minus 9, that is 81 disc. These 81 discs will be having two-digit number, that is from number 10 to 90. So we got 81 in the numerator and 90 in the denominator. We got our answer as 9 by 10. Got it? Let's take the second case. In the second case, what is the probability that the disk will have number that is a perfect square number? So we are having the disk from number 1 to 90. Which numbers are a perfect square number? Again, the concept of number theory is coming into the picture. So firstly, let's see what are the perfect square number. The perfect square number from number 1 to 90 are 1, that is square of 1 square is 1, 4, that is 2 square, 9, that is 3 square, 16, 4 square, 25, which is 5 square, 6 square 36, 7 square 49, 8 square 64, and 9 square as 81. So if you observe, we are getting total 9 perfect square numbers. So these 9 numbers are the perfect square number which are coming between the number 1 and 90. So in the numerator, we are having total 9 numbers, that is 9 discs having the perfect square number. And in the denominator, we are having total 90 discs. So on solving, we got the answer as 1 by 10. Got it? Let's move to part 3, a number divisible by 5. Let's identify what are the numbers from number 1 to 90 which are divisible by 5. So if you observe all these numbers, that is 5, 10, 15, 20, 25 up to 90, all these numbers are divisible by 5. So how many are this number? The first number is 5 into 1, second is 5 into 2, third is 5 into 3. The last number is 5 into 18. So we are having total 18 numbers from number 1 to 90 which are divisible by 5. So we got 18 in the numerator and 90 in the denominator. So on solving, we got our answer as 1 by 5. Got it? In the third case, the number divisible by 5 are total 18. So we have done with this question. Let's move to the question number 19. A child has a die whose 6 faces shown the letter as shown below. The die is thrown once. What is the probability of getting first case A, the second case D? So let's observe the question. This is a special type of die, not the standard die having a number 1 to 6. It is having number like A, B, C, D, E and again A. A is repeating 2 times, B once, C once, D once and E once. So this is a die and we have to find the probability of getting the number A. So let's use the formula of probability. In the denominator, the total possible outcome will come, that are total 6. So these 6 numbers or the 6 output will come in the denominator. Let's check out the numerator. The favorable cases of getting A are 2 favorable cases. So these 2 A's will come in the numerator. So we got 2 in the numerator, 6 in the denominator. Our answer is 2 by 6. That is 1 by 3. Okay. In the second part, we have to find the probability of getting D. The denominator will remain same, that is 6. In the numerator, the possibility or the favorable cases of getting the letter D is only 1. D is not repeating, it is only once. So 1D will come in the numerator. So we got our answer as 1 by 6. So we have done with this question. Let's move to last question, question number 20. Before moving to the last question, note that this complete lecture is part of the complete series on probability for class 10. And the link to all the videos given in the description. Do not miss the theory part and the exercise and the question part. Those all parts are very important, and once you have done the theory part, you will be able to solve all the questions of the probability. So let's move to the question number 20. Suppose you drop a die at random on the rectangular region shown in the figure. What is the probability that it will land inside the circle with diameter 1 meter? So we are having the figure. The rectangular region is given 3 by 2 and the circle is also given whose diameter is given as 1 meter. One die is rolled on this rectangular board or the rectangular region. What is the probability that this die will land in the circular region? So let's use the formula of probability. We will start with the denominator, that is total possible outcome. So what is the total possible outcome of this question or the rolling of the die? The total possible outcome is the area of this rectangular region. This complete rectangular region will come in the denominator because that is the total possible outcome. We are rolling the die on this rectangular region. So that will comes out to be 3 into 2, that is 6. So let's move to the numerator. The favorable case, we have to find the probability of getting the die on this circular region. So that is our favorable case, the circular region. So this circular region of diameter 1 meter will come in the numerator. That is the area of this region, that is pi r square. Diameter is 1 meter, so the radius will be half meter. So we got pi r square as the area, that is pi 1 by 2 square. On solving, we got the answer as pi by 24. So this is the answer. We can rewrite pi as 22 by 7. So we also got the answer as 11 by 84. You can use any of the two. Just on solving, we got the answer as 11 by 84. So students, we have done the question number 20. So students, thank you very much for being with CREATA classes. Hope you have enjoyed our video. In the next lecture, we will take down question number 21 to question number 25. So that's it for this video. Thank you very much. Meet you in the next lecture. Bye bye.